The question is, find the following antiderivatives, and there's two. So antiderivative basically means integral, and because there's no limits on that integral, that's an indefinite integral, which means that any constant added on to whatever my answer is another answer. So I should just make sure I put a plus c on the end when I've finished. So and also an antiderivative means it's something that differentiates to give what I've got. So if I can think of that off the top of my head, then that means the question will be finished. So the first one is the integral of 4x cubed plus sine 2x plus 3 dx. Well, the rules of integration tell me that I can integrate each term separately. So anything that's separated by a plus or a minus, I can integrate separately, and I'll get the right answer. So let me do them one at a time. I have, the first one is 4x cubed. The rules of integration also tell me that if I have a constant multiplied on, not added, but a constant multiplied, then it will still be there when I finish. So the integral of 4x cubed is 4 times the integral of x cubed. So I'll leave my 4 there, and then I do the integral of x cubed. Now, x cubed is just a power, so I increase the power by 1 to give me x4, and I divide by the new power. Okay? Because that's the opposite of differentiation. In differentiation, you times by the current power and then put the power down by 1. Now we're
increasing the power by 1 and dividing by the new power. So that deals with this one. We can move on to the second one. So we need to do the integral of sine 2x.
Well, I know how to integrate sine x. The integral of sine x is minus cos x, because the derivative of cos is minus sine, so the integral of sine is minus cos. So minus cos, and that 2x is trapped inside the bracket, so I need to leave it there. But I really should cope with that somehow. With the chain rule, with differentiation, I had to multiply by that 2. So with integration, which is the opposite, I'll need to divide by that 2. So it'll be minus a half of cos 2x. Okay, now I should just remember that that will only work if the derivative of the inside is just a constant. I won't be able to do that if I cos x squared. I couldn't just go, well, that's sine x squared. I couldn't just go, well, that would be minus cos x squared divided by 2x. It's not going to work. Okay, so that's that one. Now let's move on to the next one. It's just a 3. Okay, well, let me just think. If I had differentiated 3x, I would have just got a 3. So integrating the plain constant, you just stick your x on the end. And that's also because 3 is really 3 times x to the 0, so you put the power up by 1 and divide by the new power, so I end up with an x to the 1. Alright, so that's that one. And because any constant added on, if I differentiated, that constant would disappear and give me this original answer of 4x cubed plus sine 2x plus 3, I need to put one over here. Okay, so I put the c there to indicate that any value of c would work just as well. So let me just simplify it. X to the 4 minus a half of cos 2x plus 3x plus c. Now we can just check, just in case, by differentiating to see if this actually works. So let's just check to see if that really works. So when we differentiate x to the 4, we times by the current power and then make the power 1 smaller. Okay, and then we'll have minus a half times the derivative of cos is minus sine, and then because of the chain rule, we'll have to multiply by the inside, and then we'll get 3, and then the c will disappear, and so that would be 4x cubed. So we've got a minus and a minus, so they cancel out, and the 2 and the half cancel out. So, yes, it does work after all. Alright. Well, the next part, the thing I have to integrate is this. So, b, the integral of x cubed plus 1 on root x dx. Now that doesn't look too easy. I mean, for differentiation I've got a quotient rule, but there isn't one for integration. There is one for multiplying stuff, but it's still really complicated, and I don't think we've learned it in 1MA, so we're going to think of something else to do. Well, I could just divide each of those things separately by root x, and that might make it easier, because root x actually is a power, isn't it? It's x to the half. If I could write everything as a power, like as a power of x, then I could just use the ordinary rule of put the power up by 1 divided by new power. So let's just rewrite that then. So that would be, let's see, x cubed plus 1 divided by x to the half. Okay, so division works, expanding a division works the same as expanding brackets. That's x to the half, x cubed on x to the half plus 1 on x to the half. So x cubed divided by x to the half would be x to the 3 minus a half. So you subtract powers when you divide. So that would be x to the 2.5. So x to the 2.5, which would be 5 halves, plus 1 on x to the half would be x to the minus a half dx. And that I know how to integrate, because I just use the ordinary rule. Put the power up by 1, divide by new power. So dividing by 7 halves is the same as multiplying by 2 sevenths. Put the power up by 1, so minus a half plus 1 gives me plus a half. Divide by new power, so that would be timesing by 2 over 1. And then that's done, and I just put a plus c. Now I need that plus c, again, just to go over it one more time, because any value of c there, when I differentiate it, would disappear and give me my original answer. So that ends the question.